Hi, my name is Jeff Harris, and I'm going to talk to you today about honeybees. I've worked with honeybees my entire life, about 45 years or more. I've worked with bees, and they're very near and dear to me. And of course, they're very important for humans. They pollinate our crops. That's the major value we get out of them, but of course, we also enjoy their honey. So what I hope to do in this talk is show you how they live and how we keep them in hives, talk about the different members of the family, the queen and the workers in particular, and then talk a little bit about a kind of behavior that bees do in the springtime that's known as swarming. So to start off, let's talk about how bees live. They live on wax combs, and beeswax is a substance that they actually make from their own bodies. When they eat honey, they can actually convert some of the honey into fat, and this particular fat is beeswax. And they actually live in it. Um, and what they do is they secrete these. I'll show you in the next slide that they secrete the wax from their bellies. They mold the comb, and then they hang these combs from a strong supporting structure, and it's usually inside of a hollow tree. But sometimes in nature you'll find colonies like this. And the reason I wanted to show you this is just to show you that in nature bees like oval combs, but you'll see in a few minutes when I show you our hive design, we kind of convince them that we need them to fit our boxes, which are rectangular or square. So we have to trick them a little bit by giving them something to build their comb on that's not very natural, and they just respond and build comb anyway. And like I said, they actually secrete the wax. This is a scale of wax. There's another one, another one. They're special glands. This is the belly of a worker bee, and she's secreting wax. And what she does is she secretes wax scales, and other bees help her. They use their mouths and take that wax, and they mold it, and they build the natural comb on which the bees live. Now, what I want to do is show you how we adopt that comb production and put it into a square box. Beekeepers keep honeybees in artificial trees that we call hives. Ours are rectangular rather than being circular, which is what bees are used to in nature. We use rectangular or sometimes square-shaped hives. And inside these hives, I'm going to take the lid off here so that you can see what we have inside. This is a hive before we add bees to it. And when we pull the lid off, you'll see that there are 7 frames in this particular hive. This is a colony hive designed for small colonies. But there are 7 frames in there, wooden frames, and each one of these frames has a steel wire woven through it. And we'll get a better look at that here. The wire is put in there because what we're going to do is we're going to melt a sheet of wax onto that wire, and that wire is there to give the comb support when the bees build their new comb on that sheet of wax. This sheet of wax is called foundation, and the idea is we give them a starting point. It's like the foundation of your house. This sheet of foundation has the imprint of the hexagon of the combs that bees normally like to build. And what I'm going to do here is use a car battery, a 12-volt car battery, to heat up that wire. That's one strand of wire that's weaving through that comb, and if you connect the ends of that wire to a car battery for about 10 to 15 seconds, the wire will get really hot and the wax will start to melt onto the wire, and then once you see that happening, you disconnect the battery and let it cool, and then that wire will basically stay in the middle of that comb as the bees build the comb and give it strength so it won't sag under the weight when they put honey and stuff in it and it gets heavy. So it's a trick that we use to help strengthen natural comb when bees build it in our boxes. And in this case, it's melted, and I'm about to pick up the comb, the frame, just to show you that the foundation is melted in place and held tightly on that wire. And then what we do is we give that to bees, and they will secrete wax from their bellies and put it in their mouth, and then they mold comb out of it, and that's what's showing here. And they add their comb onto those hexagon divots that's on the foundation and raise it. And this is a section of bees just starting to build comb. So this is a diagram of a pretty typical beekeeping hive, and it just shows the major components. Each hive has a floor, it's a wooden floor, and then each box contains these frames that hold our wax foundation, and we have different sized boxes. And then we have a lid to keep the weather out. And what you need to notice about these hives is we can add boxes to make the tree bigger, or we can take boxes away to make it smaller when the bees aren't growing as fast as they do in the springtime. And so because we have different size boxes, we also have different size frames that can hold different size foundations, because we need the right frames to fit the right boxes. And this is just an example of showing, this is what we call a deep box. It's the one we usually give the queen for laying her eggs in and raising the baby bees. And you can see this is a sheet of foundation, and then this is the comb the bees have made from that foundation. And what's really cool is the frames are designed to where when we pack it in properly, that bee space that we saw in the natural comb in the earlier slide is maintained by the wooden frames, and the bees can move freely between the combs just like it were a natural comb. And so that's one way we basically try and imitate the way bees would do it in nature in a tree. This sequence is showing a very large colony of bees. This is about 60,000 bees in this colony. And you can see it's got 3 boxes. It's stacked pretty tall. And I just wanted you to appreciate the amount of traffic that they have as they go in and out of their nest. It's just constantly, when there's a lot of flowers blooming like there are right now, bees are constantly going in and out to go get food. And of course these bees are flying quite a way, up to 2 miles, to get their food. Shows you how busy. And I'm going to be quiet in a minute and let you hear how loud they are at their nest. This is an old box that needs painting. And there you go, you can hear how loud they can be. Constant activity at the entrance. Okay, let's shift gears a little bit and now talk about members of the honeybee family. In a typical colony of bees, there's only one queen, and she's a pretty long individual. We'll talk about her in a minute. She's much larger than the other female member of the colony, which are the worker bees. Now, there's about tens of thousands of worker bees. I mean, there can be anywhere from 20,000 to 65 to 85,000 worker bees in a colony of bees. There's usually only one queen, and only in the springtime do they make a couple thousand drones. Drones are male bees, and they don't do any work, but they still serve an important function in nature. They basically carry the genes of their mother and mate with other queens. So we won't dwell on them too much in this talk. Of course, this is a honeybee queen, and she's very important to colony structure. I can't say a whole lot about her in the time we have. I do want you to notice that she's very attractive to the workers. It turns out there are odors on her body. She makes odors that are called pheromones that are very attractive to the workers. And in fact, they are so attractive that they always want to protect her and be near that odor. And they want to contact her, and it's their way of giving her a lot of attention. And when they smell the right odor, they know the queen is there and all is well. And so a good, healthy egg-laying queen like this one produces a nice pheromone, and the workers give her constant attention. And of course, her main function is egg laying. That's all she does. She's an egg laying machine. She basically, during the springtime when nutrition is really good, that's all she does all day. She can lay up to 2,000 eggs a day in the springtime, like right about now when there's so many flowers blooming. She probably drops that down to maybe 1,200 eggs a day when we start to get toward the middle of May, when less flowers are blooming. So it's important the number of flowers and the amount of nutrition coming in help control her egg laying rate. But right now, when we have a lot of flowers blooming, she's laying a lot of eggs, up to 2,000 eggs a day. And of course, those eggs are laid in the comb, and this shows a queen laying an egg, and those eggs hatch within 3 days and become larvae. And those larvae are fed by nurse bees. They feed them jellies. Basically, nurse bees eat pollen or bee bread and convert it into jellies. And those jellies are fed to bee larvae, and those bee larvae grow in those jellies. And then after 5.5, 6 days of being fed those jellies, the worker bees put brown caps on the cells so that the larvae can pupate. This is a larva getting ready to transition into a pupa. And they protect that larva with a brown cap. And so for the rest of its pupal development, there's this brown cap on the cell. And then on the 21st day after the egg is laid, the worker bee will actually chew her way out and join the rest of the nest to become a member of the family. That worker bee that will then live only 6 weeks as an adult bee and then die. The first 3 weeks of her life she'll spend doing indoor tasks, which is like building comb, cleaning the nest, feeding baby bees, bee larvae, and then the last 3 weeks of her life she will spend going out to look for food. This comb shows capped brood. All of those tan cells, the lightly tan cells, are bee pupae that have those brown caps on top of them, protect them while they develop. In many ways, the worker honeybees are the most important individuals of the colony because they do everything that's important for the colony's survival except for egg laying by the queen. They basically build the nest, protect the nest, raise the young, and collect food. Those are all very important functions for the survival of the whole colony. So workers, we're going to spend most of our time talking about their foraging. They don't start going to get food. We call that foraging. Looking for food is called foraging until they're about 3 weeks old. And this shows a worker honeybee using her tongue to basically suck the nectar out of flowers. And if you look closely at a honeybee's tongue, it's a very elegant soda straw. They can use it to lap up, like you see those bees on the left, they're sucking up sugar syrup using that tongue. And what they do is when they suck it into their mouth, it goes into this special place called the crop or honey stomach. And this is where they carry the nectar from flowers when they're flying back home to the nest. And then when they get back home to the nest, they regurgitate that nectar into comb, and then they start turning it into honey. So that's how they carry the fluid back to the colony. Now, the other thing bees collect from flowers is pollen. And pollen is basically produced by the flowers for their reproduction. And what happens is the bees are so hairy that while they're collecting nectar and pollen, it collects on their hair, and they comb themselves, and then they pack the pollen on the back of their legs, and they carry it to the nest where they will store it in combs. Here's a worker bee who's moving from clover to clover collecting nectar. And in the next sequence it'll be brief after she goes from flower to flower. I'm going to show you a returning bee to a hive, and you can see pollen loads on her. If you look closely as she comes, there she goes. She had pollen loads on her legs, and there's another one right there. So I just wanted to show you how they carry their food back to the nest. When bees return to the nest, they regurgitate the nectar into their honey cells, and you can see the liquid there, and it will become honey, and then they pack the pollen as bread into the combs like you see in the center there. One of the coolest things that bees do is they communicate to each other. They can tell each other where food is located. And I can't give you a lot of details, but basically they can use the sun as a compass, and they can measure the angle between the sun and where the food is, and then they come back to their hive and they dance. And this is a typical dance. It's a figure 8 dance. It's called the waggle dance. It's called the waggle dance because when the bee is in the middle of the dance, she shimmies her abdomen, and then she goes around in a circle, shimmies her abdomen, and goes around this way, and then shimmies her abdomen. And the number of times she shakes her abdomen is kind of correlated to how far away the food is. And so it's a very elegant way to communicate to your nestmates how to find food. And I didn't have a video of the dancing, but I did have a picture of a bee that was dancing. So you can see how the other workers surround her to interpret her dance as she's waggling right there. That's why her abdomen's blurred. And the other bees are trying to read her dance so they know where to go to find the food. It's a pretty cool thing about bees. Finally, I want to end with swarming. Swarming is a behavior that colonies do when they outgrow their nest in the springtime. What happens is they split in half. The old queen leaves with about half the bees to find a new home, and the other half stay in the old home and make a new queen. And beekeepers love it because if they find a swarm, they can shake them into a box and take them home, and they have new bees. Here's a swarm that I've had on a fence post. Pretty easy to catch. I was able to brush the bees into a box, and after they settled down, I took them home and I had a new colony of bees. This is why beekeepers love swarms. This is a swarm that I captured on a patio, and what you see here is I've already found the queen and put her inside, and these are the workers responding to the smell of her odor inside that box. And what's interesting is there are workers along the way who know that the queen is in the box, and they're also fanning a booming signal that says the queen is this way. And that's what those workers are doing there. I want to thank you for your time. I know this was fast, and especially at the end, I was running out of time. Anyway, thank you for your time. Bye.